This conference
Let's
will
give a
now
couple of
be
minutes for
recorded.
yeah. Let's give a couple of minutes for others to join. Um, while let me introduce myself. I'm Suresh, having close to 9 years of experience into this data-related technologies. My current role is a data architect, where I would be involved in designing end-to-end pipeline, starting from ingesting your data from the source till we made data available for consumption, be it for AI or BI. Okay, and I have been training folks on big data and related technologies from past 5 years. From 2016, trained more than 3,000 students on technologies starting from MapReduce till the latest technologies in big data Spark. Okay, and I have experience working in various domains. Started with manufacturing, then retail. I have worked in finance domain, and yes, currently I'm working in digital marketing domain. Okay, leveraging big data in digital marketing domain. Right now, I would like to hear from you. I mean, you can either use chat window or you can unmute yourself and talk. While others join, can you please ping one line about your introduction? Like, I could see your names. I just want to know which technology you are currently working on and your experience. That would give me some understanding on where to get started with this demo. You can use chat window, guys. Let's try to make this session as interactive as possible.
Hi Suresh, my name is Oma. I'm having around 9 years of experience in IT. Currently, I work on the technologies, the PL SQL developer. So I work on the data warehouse side. So the core part is my background. I would say as an Oracle developer.
Okay.
So yeah, I work for the telecom network company in US. That's all.
Okay.
My background.
Thank you.
Thank you.
Uma, are you from the previous batch?
No, this is my first
Okay.
class.
Okay. Okay. Because I have the same student. I mean, I have a student with the same name who attended
Mm-hmm.
my previous batch.
Mm-hmm. Okay, yeah. Yeah, this is my first class.
Doing Okay. Okay. So doing my masters in business analytics. Okay. Having 3 years of experience. Currently working on ML background. Okay. Cool, then let's get started. Okay, so let me first give you agenda of today's session, today's demo, full stack development. Okay, yeah. So first things first, I'm gonna start with the definition of data, and then we'll try to understand this term big data and the technologies that will help us to develop applications on big data, or develop applications or data pipelines where we build different data pipelines. And once we are done with that, I'm going to walk you through different rules that revolve around this term called data. So I would clearly distinguish between who is a data engineer and a data scientist, and a BI report, or we call them as data analyst as well. Okay, and then I'm going to walk you through the course content which we would be discussing for next couple of months. Okay, and at the end of our session I'll be taking the Q&A, questions and answers. Okay, so I have 15 minutes scheduled for demo and 10 minutes to take up your questions. Okay, so let's get started. As I said, let's try to make this session as interactive as possible. So before we jump on to big data and other things, what exactly is a data? we keep hearing about this term data. So what according to you is data, guys? You can share whatever you know. Like I said, you can use chat window, you can unmute yourself and you can talk. And you can also send your answer only to me. In your chat window, you can select only me. Uh, it's my name is Suresh. Okay, and you can send it only to me if you want to. But let's try to have this session interactive. What is data according to you? Okay, cool. Let me tell you guys. Data is nothing but a collection of raw facts. It's a bookish definition. So bookish definition, collection of raw facts. Uma says data is information. Okay, yeah. Like I said, the bookish definition of data is collection of raw facts. Seed collection of ideas. Okay, cool. So in our general usage, we use data and information, these terms, in a wrong context. Okay, so let me explain the difference between data and information as well, right? I don't want to get into any bookish definitions, but to give you a good picture of what exactly data is, it's some numbers and some attributes, as simple as that. Okay, so every day in your work, once you get into any of the data roles, you would be seeing some numbers and some attributes. Pretty simple. Okay, so I'm gonna use retail business as an example because most of us are familiar with retail business. Okay, because we have been using different e-commerce websites, right? So we have some understanding on this retail business. So I'll be using that as examples. Okay, so talking about retail business, the first and foremost thing they would need to have is customer details. Okay, customer details. So for example, if you are logging in for the first time into a e-commerce website, the first and foremost thing you would be doing is to register. Okay, by providing your details like first name, last name, your email ID, and then you will be asked to choose a password, and then other details. Okay, so usually whenever I'm using this word details, in that context, we use information like this name, first name, last name, email. We usually refer it to as an information, but that's not. Okay, so this is what we refer to as customer data. All these details put together is what we refer to as customer data. Okay, it has different attributes like first name, last name, email, password, and then your addresses. Okay, and then talking about product data, the products which they sell on their platform, they'll have different attributes like product ID, product category, and then the seller of that product, price of that product, so on and so forth. Okay, similarly talking about the sales data, say for example you have purchased a product, they'll have every single detail about that particular purchase. Okay, like the product what you have purchased, and then to what category it belongs to, the price of that product, and then selling price of that product, and then quantity you have purchased, so total what they have got. Okay, and then your mode of purchase, the status of the delivery, so on and so forth. All these things would come under the sales data. Okay, so in general context, whenever you hear this term data, you would get to see some attributes or numbers, as simple as that. But like I said, the bookish definition of the same is collection of raw facts. Okay, now let me come back to information. What is information? Like I said, we keep using this term information in a wrong context in our day-to-day usage. Okay, so information is nothing but the useful data. Information is nothing but the useful data. Okay, let me explain. Say for example, I'm running a retail business. Say for example, I'm running a retail business. Maybe um, maybe Manish or Sid came to me to understand how my business is happening. If I give them the sales data, will they be able to understand anything at a very first glance? Definitely not. Definitely not. Okay, instead of giving them some data like that, what I would do is maybe I would calculate the average sales, and then I would calculate sales every quarter. Okay, and then I would calculate what are the top 5 sold products, and also I would calculate maybe top sold product for every month. Okay, because every single month the same product will not be the top sold product, definitely for sure. Okay, so for example, in summer, a hoodie or a sweater cannot be the most sold item. Okay, so likewise every month the purchase trends would change, right? So if I could get the details of these things, and if I provided these things to Manish, he would be able to understand, okay, this is what's happening with this company. Average sales are good. If I see quarterly sales have been increasing, maybe Q1 to Q2, Q2 to Q3, Q3 to Q4, sales have been increasing, because he could see that numbers. Okay, and then, okay, these 5 are the top sold products. So maybe if he wants to start a business in the same region, he would be targeting to acquire the similar inventory. Okay, so this is what we refer to as information, guys. This is what we refer to as information. Information could be as simple as calculating a sum or average, to as complex as running a machine learning algorithm to extract some insights. Okay, so the process of extracting information could be, like I said, doing a simple operation like sum or average, to running a complex machine learning algorithm. Okay, so our day-to-day life would revolve around the same activity, extracting information from data. Extracting information from data. This is what we typically do. Okay, now talking about data, we have different classifications. So one classification is types of data, structured, unstructured, and then you have third classification, semi-structured. Okay, in addition to this classification, we have another classification, that is transactional and historic data. Okay, so structured data would store data in rows and columns, guys, in a tabular format. I'll be just giving you a high level overview. I'll not be deep diving into these classifications. I mean, in our sessions, I'll be doing that anyway. But keeping the time constraint in mind, I'm just gonna give you a high level overview. Okay, structured data is something which is stored in tables, guys. The data that is stored in your database management systems, RDBMS systems. Okay, and then unstructured will not have any attributes associated. So any data that you store in your files, any files that belongs to multimedia, okay, and then all these can come under unstructured data. So typically the data is not stored in a tabular format, and it have a lot of textual content. Okay, and then semi-structured data, name itself is indicating it's neither structured nor unstructured. So basically semi-structured data would also have some structure attached to it, but the data is not typically stored in table. Okay, it's not as complex as unstructured data, and it's not as simplified as structured data. Okay, perfect examples could be JSON data, your XML data. Okay, these are the perfect examples for semi-structured data. Okay, so for example, if you talk about JSON data, JSON stores data in a key value space, something like this, maybe name, Suresh. Okay, and then age 28, maybe location Hyderabad, something like this. Now, if you see, it has some structure attached to it, like this name, age, and location. By using these attributes, we are attaching some structure to it. We are attaching some structure to it. But is it typically stored in a table? Definitely not. The data is not in the form of rows and columns. Okay, so if the same data has to be considered as unstructured, it would be something like this. My name is Suresh, my age is 28, and I'm based out of Hyderabad location. Okay, if the content is something like this, then we call it as unstructured data. And then talking about the tabular format of storing the same thing, we'll have attributes name, age, and then location. Then we'll store the values in rows. Suresh, age 28, location Hyderabad, something like this. Okay, and now let's jump on to transaction and historic. Probably once we are done with this classification, then I'll be explaining why I have got you into this context. Okay, transaction and historic data. So transaction data is nothing but your current data. Transaction data is nothing but your current data. Okay, usually database management systems are used to store this data. I would say RDBMS. Historic data. Usually historic data is, uh, you know, I would say it's not required for your current transactions, but you cannot afford to lose that data. I'll explain. Usually this historic data is stored in data warehouses. Okay. Now, um, let me talk about this current versus historic data or transaction versus historic data. Yes, historic data used for reporting purposes, not just for reporting purposes, but used for AI and BI, I would say. AI and BI, I'll get back to that. Okay, so transaction data is your current data. Like I said, anything you can update can be considered as your transaction data. I'm giving you some thumb rules, guys. These are not actual definitions, but I'm giving you some thumb rules. Okay, your login details. Okay, your login ID and your password, right? They are example for transaction data. Okay, and then once you got into the website, the product catalog you are seeing is the transaction data. Okay, and then once you have purchased a product, your data would still be considered as a transaction data until it is delivered and your return period is over. Okay, and then your personal details stored on that website. Yes, again, example of transaction data, like your payment details, and then your address details, so on and so forth. Okay, now let's assume that your product has been delivered, and then the return period is also over. With that, your connection with the retailer ends. Okay, so anything related to warranty and other terms and conditions, you might have to reach out to the product owner or the product vendor. Okay, so what does that mean? Can that e-retail site afford to lose the data because it's no longer required? Definitely not. So they would be moving that data from RDBMS to data warehouse. They would be moving that data from RDBMS to data warehouse. Okay, so that is what we refer to as historic data. You might ask me, boss, in data warehouse, do we have only historic data which is not in use? I would say historic data, but definitely I wouldn't say that they are not in use. Okay. So usually what happens is with historic data, they do a lot of analysis, guys. The reason being, they would get insights on how their business is going, and they would get insights on what has to be done next would be answered by the historic data. So all these questions around, what, how my business is going on, and what I have to do for improving my business would be answered by this historic data, by looking at your purchase details. So a lot of analysis would happen. Okay, I'm not sure how many of you are joining from Indian location, but here we have two major e-retailers. One is Flipkart and second one is Amazon. Amazon, it's global. Flipkart, it's only in India. Okay, so many times in a year they would come up with sales. Okay, like Big Billion Sale or Great Indian Sale. You know, they name it differently, but yes, they would come up with some sales where they would give you huge offers on wide range of products. Okay, so they just can't give offers like that. Okay, you know, saying that maybe this product is 50,000, then reduce 2,000 or 3,000, or maybe some product is 20,000, just reduce 5,000. No, definitely not. They will have to do a lot of analysis in order to create that win-win situation between business and customer, because you all know pretty well this is a B2C business. Okay, so that's how it works. Now, what are the historic data that is stored here would be leveraged in order to do these operations, AI or BI. AI, artificial intelligence, BI, business intelligence. Okay, so when I say AI, everything related to your data science or whatever. Okay, your data science, machine learning, deep learning, NLP, you call it with various names. At the end of the day, what you're trying to do there is understanding patterns, and then predicting what could be the next thing. Okay, so these are the things you are doing over there. And next thing, BI. Like I said, I cannot just give my data like that to my higher management. Instead, what I would do is I would create a beautiful visualization. I would create a beautiful visualization where I can display all the insights I have gathered from my data, so that they can easily understand. This is what we refer to as business intelligence. We also call it as reporting. We also call it as data visualization. Okay, there are a lot of names for the same thing, and we have tools like Tableau, Power BI, MicroStrategy to perform these kind of tasks. Okay, there are a lot of other tools as well, but to name a few, Tableau, Power BI are the most widely used. Then MicroStrategy. Okay, now you might ask me, boss, where big data is related to whatever we have discussed. Okay, so at this point in time, everything looks good. At this point in time, everything looks good. You are happy with using your existing architectures like RDBMS. You are happy with using your existing architecture with data warehouse like Oracle data warehouse, or um, using a ETL tool like Informatica or Talent or whatever. Okay, but where does big data came into picture? Okay, first things first. So talking about historic data, the more is the relevant historic data, the better insights you would get. Okay, when I use this word relevant, it makes a lot of sense. You cannot, it's always relevant, indicates in terms of time period. Okay, so in order to get some good results, I don't really need the data before 10 years. Say, for example, I'm doing some stock marketing. I wouldn't be definitely interested in knowing what happened in 2002 and 2003. That's not going to help me. Definitely not. Okay, not just stock marketing, there are a lot of other trends as well. Maybe in order to analyze the current trend of e-retail sales, I cannot go back to 2005 or 2004 to understand how eBay have done there, because people, the usage of internet by people have grown leaps and bounds in these 15 years. Okay, so always that relevancy is important. So under that relevancy, the more data you have, the more accurate your predictions can be, or the more accurate your results can be. And second thing, you cannot just rely on a single source of truth. Okay, maybe I'm an ABC company, and I'm selling some products on Amazon platform, and I'm selling same products on Flipkart platform, and also I'm having my own website. Okay, Okay. And then I'm also doing Google marketing, Google ad marketing, and then I'm doing campaign. I'm running campaigns through Facebook. I'm running campaigns through Instagram, and I keep tweeting about my products in Twitter. Okay, social media, I would say, right? And then I have a lot of other channels as well for selling this. Maybe on every weekend I will send my marketing persons to go and market my product. So there are a lot of different channels of selling my product. Okay. And then since I have a lot of channels, there are a lot of channels from where I can get data from. Okay, I would get Google data, Google ad marketing data, and then since I have a website, I can get Google Analytics data. For every website, you can enable this component called Google Analytics, guys, and that Google Analytics would give you a lot of insights, like how many users have been logged into your website, and then what are the different products they have seen, and then what are the products a lot of people are interested in. You would get to see a lot of interesting insights using Google Analytics tool. It's a paid tool. Okay, yeah, I would get some data from Google Analytics, and then I would get some data from the marketing persons who are doing this physical marketing. Okay, and then I would get some data from the ads I'm running in social media. We call that as social media analytics. Okay, and then I would get data from Amazon and Flipkart, and again, having having analyzing my data wouldn't be sufficient. I'll also have to analyze my competitors data, so I can purchase the competitors data from this third party platforms like Amazon or Flipkart. Maybe mine is ABC company, they wouldn't be selling the data. So for example, I'm purchasing air conditioners. Like me, there are 3 or 4 more companies who are also selling air conditioners. Okay, so they wouldn't be telling me how other companies are doing on a company base. Maybe there are 3 companies who are selling air conditioners on Amazon platform XYZ, and then PQR. ABC is my company, so this Amazon wouldn't be selling the data how XYZ is doing and PQR is doing. Okay, I'm taking Amazon as an example, guys. I'm not saying that Amazon is selling the data, but this is what actually third-party tools does. So what they would do is they would summarize how these 2 companies are doing together, and they would be giving the numbers to me, like my numbers versus industry numbers. My numbers versus industry numbers. Say for example, I have managed to sell maybe 560 air conditioners in the month of June, and how many air conditioners were sold by the industry, rest of the companies. Okay, when it comes to rest of the companies, again you'll have categories like how many 1-ton ACs have been sold, 1.5-ton ACs have been sold, so on and so forth. So a lot of detailed data you would get. Okay, and the level of detail depends on how much you are spending, okay, to purchase that data, right? So now I would be getting data from these guys. Now all these data has to be put together and do analysis, and I need one platform to do that job. Will I be able to do that using my RDBMS? A big no. Will I be able to do it using my data warehouses? Again, no. To some extent, yes, but definitely no for all the cases. Now what is my answer to this question? Is using big data platforms. Using big data platform. Okay, I'll just give you a simple example, guys, of our recent project, right? We are a team who build solutions on big data platform. Okay, when I say big data platform, we will be using all the tools and technologies related to big data. Okay, now we are the team in our organization who would build big data solutions, right? And recently we have acquired a company. Okay, I don't want to name where I'm working in, but yes, we have recently acquired a company. And then when we want to do a merger project where we'll have to merge our data with their data, though we are doing a similar business, there is there are a lot of nuances which are different from our company to their company. Okay, so we have a technology team who are completely working on managing our data starting from RDBMS till data warehouse. So there was a requirement who can take up this task. Okay, we are the team who went right up front and took up this project when nobody even dared to touch it, because the deadline is 2 to 3 months, not more than that. Because during this lockdown time, we have to analyze as quickly as possible, and we want to be the first one to be in the market with different solutions after this merger. Okay, so we cannot afford to spend like maybe a year or 2 or 3 using tools like Snowflake, or maybe using tools like Informatica or ETL or whatever. Okay, so I doesn't mean that using those tools your solution cannot be built, but big data is the solution when it comes to doing these kind of projects. Okay, and we were able to quickly build the uh, project we are looking for, and we are happily able to deliver it. Okay, the only reason is no matter what your data source is, it could be a CSV file, it could be a JSON file, it could be a REST API, it could be a streaming data, it could be data already residing on any tables, it could be anything. We will be happily able to pull it and then do whatever is required. Okay, that's the beauty of big data stack. That is the reason why industry is looking at big data technologies. Okay, you might be hearing different things like Hadoop is dying, or a lot of things are happening in I mean, you keep on hearing to those things. I would be talking about that as well. Now before we go there, I also want you to understand what is big data. Okay, so big data doesn't have any um, standard definition, guys. So usually we call any data which cannot be handled by a particular machine as big data to that machine. It's a relative term. It doesn't have any thresholds, like TBs of data is called big data, or PBs of data is called big data. No, there is no such restrictions on this term big data. Okay, so big data is anything which cannot be handled by a system. It could be as less as 1 GB. Okay, if you have an infrastructure which will not be able to process 1 GB of data, that 1 GB of data would be big data to that system. Okay, so this is what we call as big data, simple definition of big data. Okay, and now the you might ask me a question, was why the data cannot be handled by the existing infrastructure in our previous example. It could be because of these reasons. One is volume of data is so huge that it cannot be processed by your existing infrastructure. And then variety. Okay, maybe I have an unstructured data or maybe a semi-structured data, and I'm using an RDBMS tool. Definitely you cannot store and process unstructured data using your RDBMS tool. Okay, so variety of data, types of data, and then velocity. Okay, so this velocity comes into picture when you are using streaming data. Streaming data is nothing but continuous generation of data. One best example for this could be the data that is getting generated from your sensors. The data that is getting generated from your sensors. Okay, there are a lot of sensors in today's world. There are a lot of sensors in today's world which are generating a huge amounts of data. Okay, let me tell you one example that happened with one of my colleague. Okay, he bought a Skoda Kodiaq car, Skoda Kodiaq, and we usually work in 2 to 11 shift, 2 p.m. to 11 p.m. shift in India. Okay, so that we can have some overlap with the US folks, and can have our meeting scheduled during that overlap time. So one day we have to work till 2 a.m. in the night, and then he has to drive around 35 to 40 kilometers to reach home. Okay, so he was telling us that night when he is driving his car, at some point he heard some. Okay, the moment he checked the dashboard, the car is asking him to take a break, take a tea break. Okay, the reason being his driving patterns were recognized as sleeping driving patterns. Okay, and the very moment car stopped and started beeping till he disabled that beep sound. Okay, so cars have become so intelligent, they were even able to understand that a driver is sleeping. How that is made possible? From this data called OBD, onboard diagnostics data. Okay, so OBD, onboard diagnostic data, we have these devices installed in your car which would generate the data, like how your car is, at what speed your car is moving, and then in what direction your car is moving, and then how your engine is being utilized, so on and so forth. There would be a lot of data that is coming under this OBD, onboard diagnostics data. Using this, you can do wonders. And talking about this OBD data, the reason why I have taken OBD data is it would give you good understanding on two terms: real time and streaming. Okay, say for example, my colleague should receive message as soon as he was driving in that sleepy mode. Okay, it's not after he reaching home and sleeping. Okay, so when he's sleeping, if he gets a message saying that at 8 p.m. or at 9 p.m. when you are driving you felt sleepy, better take tea before you start journey, it doesn't help him. Okay, so this is what we call as real time. Whenever the data is being generated, it has to be processed as and when it is getting generated, and then some analytics has to run, and the output has to be displayed. Okay, so the best example where you can get online for these kind of problem statements is Twitter sentiment analysis. Twitter sentiment analysis, the standard example which you get in most of the online platforms. Okay, and the data is streaming because the data wouldn't get generated in batches. Every second you will receive you will receive a data point if you are traveling on a straight road, and if you are traveling on a curved road, every 5 seconds you will get a data point. It's a continuous data points. It's continuous data points. Okay, so this is the best example for real-time streaming data, guys, and that is when this velocity comes into picture. Okay, so the question you have to ask your infrastructure is, were you able to handle the rate at which the data is getting generated? If your answer is no, yes, that data is big data to your infrastructure. Okay, so most of the projects I have worked on, I have seen only these three characteristics, but in most of the websites and most of the books, you will be seeing the fourth one as well, veracity. Okay, so the definition of veracity is data in doubt. Data in doubt. Okay, like I said, I get a lot of data from different sources. How can I rely on that data, whether the data is reliable or not? Okay, who knows? Nobody. That is what we call as veracity. When you don't know about, or when you are in doubt about the authenticity of the data. Okay, so any data having any of these characteristics or one or more characteristics can be considered as big data. If your data is so huge, big data. If your data is so huge and unstructured, it's still big data. Your data is a real-time streaming data, it's a big data. Okay, and to address these problems, we have got a framework called Hadoop. Okay, so in 2014, 2015, Hadoop is a rock star. People used to get 100%, 150% hikes. I'm one of that guy who enjoyed that privilege. Okay, so Hadoop primarily uses MapReduce and related technologies, guys. Let me tell you what. You might have heard people who are saying Hadoop is dying and working on Hadoop. Okay, I still see a lot of requirements coming on Hive. I still see a lot of requirements coming on, MapReduce related tools. But one thing I have to agree is people have moved on from Hadoop to Spark, and this Spark to cloud. When I say cloud, that Spark on cloud, Spark on cloud. Spark on cloud. The cloud could be Azure, cloud could be AWS, or another most happening cloud these days, GCP, Google Cloud Platform. Okay. Earlier it used to be on-premise, where companies like TCS, Infosys, Cognizant, they used to set up their own on-premise cluster, install Spark, and have an administration team to manage that. But people have moved from that scenario to the cloud scenario. Okay. Now that people are using Spark on cloud, and the most loved distribution for implementing Spark is Databricks, have made programmers' life very easy. I still remember the pain of deploying the application I have developed on an on-premise cluster. So first, develop an application in my personal laptop. Then I would be testing it on a sample data. Then I'll have to build a Maven jar or an SBT jar if I'm using Scala to build it. Okay, and that is the real pain. If you are not coming from a technical background, that is a real pain. And one of the guy here think that he is a full stack developer. He should be knowing the pain of building a Maven project. Hope you agree with me, buddy. Okay, sometimes I feel writing complex code is very easy than building a Maven jar. Okay, because you'll have to take care of a lot of things, version mismatches, it's a hell. And once you are done with that, then you'll have to copy that jar from your on-premise cluster to your from your PC to your on-premise cluster. We refer to that node as edge node. And once it's there, you'll have to run your code on the data. Okay, this is the deployment process, which used to take at least a day or two. Okay, if something went wrong, if everything falls in your circle, then you should be able to run it in like a day or maybe a half day at least. Now talking about Databricks, you can do this entire process in like 10-15 minutes. I'm not exaggerating. Even you guys would agree once I have introduced Databricks to you, our new rockstar in Spark. Yes, people have moved on from Hadoop, but they have never went to any other technology, guys. Even this Spark or Databricks or whatever would still come under this big data stack. Okay, like I said, I have shown you the problems what the existing infrastructure have faced. So there is no other alternate. They have to rely on these tools in order to get this data going. Okay. Now talking about roles, so I have given you some picture on what will be done in a project at a very high level. But now this data engineer is the guy who would be responsible for creating a data lake. Creating a data lake. Let me explain what exactly is a data lake. Okay. Now talking about sources, the same ABC company and same thing like Google Ads is one source of data for me, and then my physical marketing data, and then the data I purchase from the vendors, I refer to as third party data. Okay, and then my GA data, Google Analytics data, and then the data that is residing in my system, in my database management system. Okay, and then the data I purchase from, I mean, my data I don't need to purchase from Amazon or Flipkart, because I would be having the stats of what I have been sold on their platforms. Okay, so let me refer to it as platform data. They are all different sources. Now I have to build the ETL pipelines. ETL stands for extract, transform, and then load. Okay, so this is the old term, but the new term for the same is ELTL. First extract the data and then load it to wherever it is. If you are using Azure, it could be ADLS. If you are using Amazon AWS, it could be S3 buckets. If you are using an on-premise cluster, it could be HDFS. Whatever it is, these are different file systems where you can load your data to. And then you use different technologies of Spark to transform it. Okay, so it could be your RDD related tools, it could be your Spark SQL, it could be your Spark streaming, whatever it takes. Okay, transform, and then finally load it to the tables. Again, load it to the tables. Again, it could be a file, it could be a table. Okay, Spark table or whatever. Okay, from where the users can consume your data from. This is what you refer to as a data lake. So data lake is a central repository where the data from different sources are aggregated as a single source of truth from which your AI guys and BI guys can consume data from. AI guys are nothing but your data scientists, so they can run their machine learning algorithms on top of this data. And then BI guys are the reporting folks who can build their reports from this data lake. Now, data engineer, the data engineer is responsible for this process. Data engineer is responsible for this process, this entire ELTL process, the modern scenario for any project, any big data project. Okay, so data engineer is responsible for doing this and making a data lake, data available in the data lake for AI folks and BI folks to consume. And then data scientist is the guy who does who models your machine learning algorithm and then create those insights required for your business to take up the decisions. And then the third guy is data analyst. So this data analyst is a separate role earlier, but in the modern organizations, data analyst role is being played either by data engineer or data scientist. So for example, in our organization, data analyst role is played by our team itself. So that is the reason we call ourselves as a data solutions team. Okay, so let's say I'm a data engineer. I build the entire pipeline. At the end of the day, I'm the one who is responsible for building that report as well. It's like build one time and then refresh it every day. Okay, no longer data analyst is considered as a separate role, guys. Either a data engineer or data scientist nowadays are playing the role of data analyst as well. Okay, now for data engineer, he might not need a domain knowledge. So if he knows what has to be aggregated and where everything has to be loaded to, that will do. But for data scientist and a data analyst, they should be having some good business understanding. They should be having some good domain knowledge. Okay, so our course would be covering all the tools that would help you to build these pipelines on Azure platform. Okay, so our course Spark on Azure would help you to build these pipelines, would help you to learn all the tools that will help you to build these pipelines. As simple as that. Now you may go through the course content to understand what would be covered as a part of our course. Okay, course content would be shared by career IT folks. Yes, now let me stop here to take your questions. We'll spend next 5-10 minutes to take your questions. Any questions for me?
Do we need to learn have a knowledge on Python to understand this Spark?
Yes, you need to learn core Python. I'll be teaching that as a part of this course.
Okay.
First couple of weeks, I'll be teaching Python. So these Spark applications can be developed on Python, Scala, and Java, guys. Python being the most used language right now in the market. It used to be Scala a couple of years back, but after the introduction of PySpark has taken it over. Okay, so I'm going to teach you Python in the first couple of weeks, and then we'll get into this Azure. And duration of this course would be 2 months.
Okay. Thank you. And so, what would be the usual training hours, Suresh?
Uh, Career IT guys would get back to you on that, Uma. We are yet to figure out the timings. So it would be in my morning and your evening.
Okay. And how about the softwares? So, do you guys provide us like an online support?
You don't need to install anything, and we don't provide anything online.
Okay.
You can be using trial versions of the respective tools.
Okay. Got you.
So
Thank
for
you.
example, Azure would give you a free subscription for 1 month,
Mm-hmm.
to get used to Azure environment. And then these Databricks guys are giving you a good amount of resources for free of cost, a lifetime. At least for now, it doesn't have any expiry. Maybe in future, if they change, I don't know. But for now, yes, you can use Databricks trial version to practice whatever that is being taught.
Sure. Sounds good. Yeah.
System configurations, you don't need to worry about system configurations as well, guys. As long as you can open a Google Chrome browser in your system, you're good, because I'm gonna use all the cloud technologies to teach you. Okay, so if you don't have any questions, please leave a feedback about this demo, guys, in your chat window. I would love to hear from you. Okay, so maybe a one line or two line, whatever you feel like, just leave us a feedback in the chat window. I hope everyone have enjoyed this demo. Would love to see your feedback before we wrap up today's session. Thank you. Thank you, Ma. Thank you, Harish. Thank you, Manish. Thank you, Ma. That means a lot.
As well as Manish.
Yeah, Manish, go ahead.
Do we do any projects like what kind of projects we will
Yes,
do
we
like
will be doing. I'll not be running the project in the session, but yes, I'll give you a couple of projects for practice. I'll explain
Okay.
what that project is all about. You'll have, you will be using all the tools you have learned in order to build that project.
Okay.
Okay. For your
Yeah.
practice, definitely I'll give you a couple of projects because, that hands-on is also very important.